Hi, and welcome in this new PepperL and Fuchs video tutorial. PepperL and Fuchs is one of the world's leading manufacturers of electronic sensors for smart factories and process automation. The company is trusted by industrial customers across the globe. In this RTMaps tutorial, we will explore how the Pepperl+Fuchs LiDAR sensor can be seamlessly integrated into RTMaps. This will enable developers to accelerate the deployment of automation projects and take industrial applications to the next level. RTMaps now supports all 2D laser scanners in the R2000 series and can support additional sensors with the existing package on demand. You can find out about all the advantages of these sensors on the Pepperl and Fuchs website or via the link in the description of this video. Let's start with RTMaps. If you have seen our previous videos and follow our YouTube channel, you should be familiar with how the RTMaps middleware works and how easy it is to acquire sensor data. First, let's start RTMaps Studio and register the RTMaps LiDAR Pepperl+Fuchs package. Next, drag and drop the R2000 acquisition component onto the diagram and configure the sensor's IP address in the component properties. We can choose the desired output format and adjust various options to improve the visualization. Now, we drag and drop the corresponding point cloud construction component and a 3D viewer to display and visualize the point cloud. In addition, let's use a sample rate component in the graph and switch the verbose sample rate option to output sample rate. Then add a gauge to visualize the measured sample rate from the sensor. In this example, the LiDAR sensor outputs 50 point clouds per second. A good sample rate provides better temporal resolution, enabling fast-moving objects and rapid changes to be captured more reliably. This is useful for applications such as obstacle detection, SLAM, and mapping, where missing points can be crucial. Let's add webcam and image viewer components to record our scene. As soon as we run the application, we will be able to visualize the connected sensors and the point cloud in the 3D viewer. You can easily navigate the 3D scene using the mouse to view the point cloud. As soon as we move the LiDAR sensor, the point cloud moves perfectly synchronously. Let's save our diagram. In the next part of this tutorial, we will add a recorder and connect it to the LiDAR and webcam components in order to log the LiDAR raw sensor data and the video stream. After collecting the data, we delete any unnecessary components and replace them with a player to replay our recording. We then select the path of our most recent recording and connect the player's outputs to the corresponding inputs. Let's start. Now we can see a real-time replay of our data in the same conditions as when it was recorded. Easy, isn't it? We save the current application and open an offline diagram with a CoreSLAM algorithm demo in the corresponding Windows version. We select the CoreSLAM algorithm component and the different viewers, copying and pasting this part of the diagram into our main application. As you can see, the RTMaps middleware is highly modular and intuitive. The CoreSLAM component expects a vector of skin distances in millimeters on its input. So we add the scan splitter component from the PepperL and Fuch package, as well as a vector scale and offset component. First, we set the float scale to 1000 in the properties. Then, we connect the output ranges from the scan splitter to the component. We insert a number converter before connecting the LiDAR data to the CoreSLAM component to ensure that the data is compatible. In the CoreSLAM component, we adjust the properties according to the LiDAR sensors in use: size, angle, duration, and detection. Run the application. We can now visualize the map generated by the CoreSLAM algorithm along with our sensor position and orientation in the map. Using our mouse cursor, we can click on the viewer to define a path planning trajectory towards the selected destination. The CoreSLAM's path planning module automatically selects the optimal path, avoiding any obstacles in the environment. That's it. You can now use the PepperL and Fuch LiDAR in any kind of advanced multi-sensor applications. I hope you enjoy this tutorial, and we'll see you in the next video.